Hi everyone, my name is Jovi. Today we will discuss regarding the power flow analysis using Gauss-Seidel method. This Gauss-Seidel method was developed by the two German mathematicians Carl Friedrich Gauss and Philipp Ludwig von Seidel. So this method of iteration to calculate the voltages of the bus in the power system or the power. But before going further, we will go back to the basic of the power system. So for example, we have a generator, okay, then transmission lines, then after that there is a load, okay, and we have a flow of current here I, and this is bus. We have a voltage here, so we have a impedance Z. Now we know that V is equals to IZ, then I is equals to V over Z, which is impedance. Okay, impedance is the reciprocal of or the inverse of admittance. This admittance we will use during the formulation of bus matrix. This is very important so that we can calculate the variables or the elements that need to be used during the calculation of voltages or power using the Gauss-Seidel method. So as we go on, for example, we have three bus system, okay, and we have the here impedance. For example, we will write this one as a, we will directly write this one as YA, and this is YB, and this is YC, and this is our bus 1, bus 2, and bus 3. And this is our B1, B2 here, and this is our B3. So we need to go back to our basic circuit analysis, like a, because we need to use a circuit analysis like a nodal here. So for example, we will use nodal in this bus 1. So what are contained in this bus? For example, we have current here, I1, and we have another outgoing current here, which is I12, and we have another current here, I13. Okay, now by using nodal analysis, I1 is equal to I12 plus I13. Then I1 is equals to, what is I12? I12 is equal to voltage at bus 1 minus voltage at bus 2 multiplied by the admittance. Okay? How about I13? I13 is equals to voltage at bus 1 plus voltage at bus 3 multiply to admittance YC. So, replacement, change this I12 to this B1 plus I13 YC. So this is your equation for I1. Now, we will go to I2. Where is I2? This is your I2. Okay? So in I2, we have current there. And going here. Okay? So the summation of I2, sorry, this is I2. So this one, I12 plus I23. So what is I12? I12 or I21. So from I to 2, from 2 to 1. So we will change this one 2 to 1. Okay? So also. Now, I21 is equal to P2 minus B1 YA. Okay, and I23 is equal to B2 minus B3 multiply to YB. Then we will substitute also. This 2, 1, we will change this one to B2 minus B1 times YA plus I23 okay. So let's go to, we're going to solve for the current at I3 in this area. Okay, so now we proceed to I3. We know that I3 is equal to I13 plus I23. So B3 minus B1 is 1 to YC plus B3 minus B2 YB. So this is the equation for I3. So all the equation we derive, we need to simplify all the equation. So by simplify equation 1. So I1 B2 YA plus so the result of this is YA plus YC Then I2. YC. Then further simplification. Dito. I3. So I3 B1 Y C minus YB B2 plus this. Why I write this linear equation? Because this one we need to use this one in the formation of the bus matrix. So bus matrix formation. That's why we need to find the linear equation. Once we get the linear equation, so we can identify, and for then the formation, we can derive the formation of the bus matrix. So this is the form. I1, I2, and I3 okay, is equal. You can find this all in all of the reference book, no, for the power system, like Stevenson or any other power system box. This is common. Y21, Y22, Y23, Y31, Y32, Y33, is for B1 or B2. This is how the form of the bus matrix. So the current is equals to Y bus times V bus. This is it. This is the admittance matrix, which we are going to use during the Gauss-Seidel method. So I will show you the formula for the Gauss-Seidel. So B sub 0 K where Y I times P, which is the active power, reactive power, which is Ki, the number of iteration, K minus 1, okay, minus the summation, minus 1 equals to 1. So this is the formula for the Gauss-Seidel method. So after the end of the iteration, you need to calculate the error. So the error okay. So there are steps for the calculation of this, the steps of the method. Steps, no? So I will enumerate the steps. Number one, we need to obtain the admittance. Obtaining the admittance matrix. Steps of Gauss-Seidel method. Then number 2, after you obtain the admittance matrix, so check the node. You need to check the node. Check or set the bus node. Number 3, you need to set the initial condition. Number 4, we need to use the nodal theorem, nodal analysis. Okay? And number 5, this is the one. Calculate the error. Once you calculate the error, then you know that it's already converged. So this is it. This is the end of the iteration. So thank you. The next video, I will provide you the calculation example of the Gauss-Seidel method. Thank you, everyone.